Welcome to today's virtual time series meetup. My name is Caitlin Croft, and I'm joined today by our very own Tim Hall, who will be talking about how he's monitoring his son's gaming computer. A couple of friendly reminders. The session is recorded, so it will be available later today. Please feel free to post any questions you may have for Tim in the Q&A box or the chat box. I will be monitoring both. And there will be some fun swag giveaways. So Tim, just be on the lookout if there's a question that you really like or whatever else. I'm happy to throw some swag to attendees. And without further ado, I will hand things off to Tim.
All right, thanks, Caitlin. And we always promise Q&A, but I try to jam a lot of content into the time that we have. So if we don't get to it, my apologies, but we'll try to get through as much as we can. Just some background. Hi, I'm Tim. I'm head of products here at InfluxData. I've been working with InfluxDB for a little over 4 years now. We launched the 2.0 version of the platform just last November, and we've been working and operating it as a mission critical cloud service for many of our customers using all the 2.0 components really since September of 2019. And so I'm going to walk through like how I'm using all of these different parts of the platform today and show you how to take advantage of it. But the impetus for the talk was really that my son here needed some projects to work on. I got introduced to computing back in this era. If anybody knows what that is, that's the original IBM PC. And when I was about his age, I got an internship to essentially build those machines and take them apart and be a technician. And so I thought, hey, maybe I'll give my son a skill and teach him a few things about how to build a PC. And so he's been getting into gaming and doing all sorts of other things. And so you can tell that the generations are quite different here in terms of the tech, but that's the kind of thing that he wanted to build. And so I really was thinking about this as if I'm version 1.0, then he is clearly version 2.0. So with that as a background, we set off to set of components. And if any of you have tried to do this, it involves a lot of research and figuring out what to get. And so I started off by figuring out what kind of processor we were going to get, what kind of video card, a fan for the CPU, thermal paste, which connects the fan to the CPU, makes a nice tight contact, some memory chips, the motherboard, obviously in the middle. There's a drive that's mostly SSD there on the side, a power supply, and of course the case that he wanted. And I highlight in green the two most expensive parts of this endeavor. By the way, this was assembled over many birthdays, Christmas time, other gifts to sort of get to this point. But the two most expensive parts of the rig are the central processor, the CPU, and that video card. And so that's going to be quite important because I hadn't honestly put together a PC here in a number of years. I've been buying them off the shelf. And so I wanted to make sure that we weren't going to ruin our investment in this little project. And so we assembled all of our components. I did, and my son and I got a lot of assistance from various YouTubers out there. And we very much appreciate all the folks that posted on YouTube. It feels like the video open source community of how to assemble and put the hardware together. And then I got to the end of this and I was like, oh, wait, we need to put an operating system on this drive. And so I said, oh, let's go with Ubuntu. It's something I'm familiar with, something we use at work. And maybe that'll be a good environment also for you to learn about Linux and how to take advantage of it. And it turns out I wasn't quite sure. There's no drive. I mean, there's a hard drive. There's no DVD drive. There's USB sticks, but how to get the operating system onto the computer. So it turns out in the 21st century, you need another computer to build a computer. And so I went through the process of downloading Ubuntu, creating an ISO image on a USB stick, And again, thanks to the open source community, there's a program called UUByte that I downloaded on my Mac for work, created the ISO editor, and then went back to YouTube to figure out how to make the machine boot from the USB stick. It was a little bit of a frustrating experience figuring all that out, but in the end, we got it all working. And so then I said, all right, I'm going to go ahead and install InfluxDB2 on this rig, get a local version of it. So I went to our downloads page. I grabbed the version for Ubuntu, and I got that set up. I installed Telegraph, basic Telegraph agent, so that I could use that to get the metrics off of the machine and get them flowing into Influx. And then it turns out that one of the features of InfluxDB 2.0 is this notion of templates. And there happens to be a community template for Linux system monitoring. So I was like, great, I'll grab that and give it a shot. So let's take a look at what that actually all looks like for real. Ooh, let's jump back into this. So I have already started Influx. I have it up and running. I actually have it running as a systemd service. And you can see when you set up the open source instance, super straightforward to get started. I'm going to put a username in. I'm going to give myself a password. There's two pieces of information you need. InfluxDB 2.0 is multi-tenant from the get-go, which means you can have multiple organizations where you partition all of the resources from data to Telegraph configurations, dashboards, and more into different orgs. So I am going to create my organization, and then my initial bucket name, we'll call it Telegraph to start. So because I know I'm going to get the stats from Telegraph. So I hit continue. We're not going to save that for now. And it says, okay, I'm ready to go. I'm kind of an advanced user of Influx, obviously, so I'll drop into advanced. And you can see it created those buckets for me. There's a home page, obviously, where I can go and check out what to do, load data, build a dashboard, etc. But what I really wanted to do was start with that Linux system template, because that looked like something that I could leverage straight away. So if I go out to our template library on GitHub, and I remember the alphabet and I hit Linux, you'll see that there's this template that's here, and it looks like it's going to give me the CPU load and memory usage and all these other things. So if I grab the URL, I can go back to templates and I can pop it in here, and I can look that up. And sure enough, here's all the resources it's going to import, everything from the dashboard to a Telegraph bucket, which I already have, some variables, and the Telegraph configuration, which I'm interested in. So if I install that template, then I can go back and I can see, sure enough, now I have this Linux system monitoring template. And if I crack that open to look at its configuration, you'll notice a few things. One is there's all these different settings. There's the agent setting. There's this output. And it says, oh, if I'm going to use this, I'm going to need to define environment variables for the Influx host, the token to use, and the organization. And so over here, I've already set up at least the settings for the organization, and I'm using localhost because that's the open source instances installed locally. Now, what I need to do, because I've created this from scratch, is I need to get a token. So InfluxDB 2.0 is secure by default, meaning that you have to use a token for all the API access. And so I'm going to go through the specific setup instructions for this, which is I've already installed Telegraph locally, but I need to configure an API token. So I can use this button here to generate a new token, which looks at that configuration and gives me read access to this specific Telegraph setup. So I'm going to copy that to the clipboard, and I'm going to replace the token that I already had when I was doing my demo setup out there. And so now the token's there. So all the latest environment variables are set. And now one of the cool things is, starting with, I think it was Telegraph 1.9, is we do allow you to load the configuration at startup from a remote endpoint. And one of the things that we've done, obviously, with InfluxDB 2.0 as part of the platform is you can actually store your Telegraph configurations within the platform so that you can use them in specifically this way. So this local host, and it says V2 API, Telegraph and then a specific ID for the configuration. And I can copy that to the clipboard and I can see if I can start up Telegraph. And sure enough, looks like it's starting. It's going to give me some stats. And so let's go see if we can check those out. So if I flip over to the dashboards, again, I imported this Linux system monitoring dashboard. And if I click on it, I should be able to see, in theory, there we go. In the past 5 minutes, I'm starting to get some stats, which is great. Like that's exactly what I wanted, except that the two most important components of the system, the CPU, which we're getting CPU stats, but I don't have the temperature. And so the thing I kept hearing about and sort of building new rigs and the new gaming system is that these systems have the potential to overheat. And I was very worried about melting down this investment that we had just made and all this hardware. And so I want to check that out. And so while this is great to just to tell me what's going on from a memory usage and so on and so forth, and networking and uptime, I'm not getting really what I want, which is I want to add these temperature controls. So within the load data section of the platform, I went in and I was like, hey, maybe there's something for temperature. And I just typed in temp, and sure enough, there's a temperature setting. So I grabbed that and I started to look at the details of it. And what's nice is this one it's very simple configuration setting. It's cross-platform, supporting both Linux and Windows, which is great. And I'll get into that in a minute. And it looks pretty simple to add. So when I selected that, and I said, all right, let's copy that whole thing to the clipboard. Then I want to go back and I want to add that to my Telegraph configuration. So if I go in here, I'm assuming that, oh, wait a minute. There's no ability to edit the config. So what I have to do instead is download the configuration and edit it locally. Now, I also want to be able to monitor the GPU. And so if I go back to the sources, I know I'm using an NVIDIA card. So sure enough, there's an NVIDIA plugin that's also available for Telegraph, and I can copy that. And if you look, it says some specific things about, hey, you need to know where this NVIDIA SMI thing is located at. So if I go out and I can say which NVIDIA SMI, and sure enough, it's located at that default path. So I've got 2 plugins I need to add to my my Telegraph configuration. So I can go ahead and download that configuration, which I did. And instead of having you watch me type it all back in, I have it here. Let's just sort these results a little bit. So here's the Linux system monitoring config, and I just added that temporary configuration, the temperature input configuration, and I've added that NVIDIA stats configuration. I'm going to uncomment this out because that is the location of where you can find those stats. And you can do other things. If I wanted to change the polling interval to be a little bit longer, I don't know that 10 seconds is necessarily what I'm after. 30 seconds should be fine. You can go through that kind of process, edit the configuration file. Now, the downside, of course, is that I've downloaded this locally. It's not pulling it from, it's not doing the cool thing where it's pulling the configuration centrally. But what I can do is use that same templating mechanism to re-import that configuration and host it centrally, assuming that I have this all right. So let's go back and let's fire up Telegraph. And if you want to see what the NVIDIA SMI process actually does, you can just run it and it spits out a whole series of stats. And then what the Telegraph plugin does, obviously, is scrape the various things that are being reported from that NVIDIA utility that's deployed. So now I'm going to stop collecting the stats using that central config. And what I'm going to do instead is I am going to run it off of that downloaded configuration. And in theory, I've got that right. You can see now in the loaded inputs that I have both the NVIDIA SMI input as well as the temp input there. So if we go back to the dashboard, let's see if it's still okay. It looks like more data is coming in. That's great. And now what we want to be able to do is we want to be able to take a look at the data that's coming off of both that temperature sensor and the GPU. So if I come in here, I should be able to see that data once it maybe hasn't been flushed in yet. There we go. So there's the NVIDIA data and the temperature sensor. So if I click on temperature sensor, you can see that there's a bunch of options here. And then I can look at the specific sensors themselves, which gives me a whole list of options. So I just want the CPU inputs, raw CPU inputs. I don't want them filtered. I don't want just the max value because I want to see what's happening as the temperature goes up and down with the actual usage. And I can go and select, it happens to be an 8-core box. So there are 8 sensors, obviously. If I click on those and I can do a mean over some time period, and there we go. We have some data coming in. So now that tells me it's operating in the range of 45 degrees C to 52 degrees C. And now that I've got that basic setup, I can save that dashboard into my Linux system dashboard, right? That cell, and I can say it's CPU temp and save that. And I can go to the dashboard, and sure enough, it's placed it a little bit indelicately at the top, but I can drag it down here and expand that. And now I've got a nice visualization for CPU temp. Let's drag that over here. And now I can keep track of that, which is great. Now I can go through that exact same process and explore the NVIDIA outputs. So if I come back to the Data Explorer, I can come through here and select up, let's say, temperature for the GPU, and then see what other values are available here. And if I just submit that, you can see I'm getting a temperature for that GeForce 2060 card that I've got in the box, and it's running at 44 degrees C. So that's great. Like I'm able to quickly do that. And so what this led me to do was continue to explore the kinds of metrics that are available on that NVIDIA card. So there's power draw, there's free memory, and so on and so forth. And so I ended up building up a dashboard, a pretty more sophisticated dashboard, which I will import and show you how that ended up. And so if I come in here, now you'll see things like the GPU temperature again is being mapped. And then I've got various other single stats here: GPU utilization, memory utilization, fan speed. And it looks like I have an error here. So let's see if we can open this up and fix that. Indeed, I parameterized the whole dashboard using variables. And so I can change that to be vBucket. And so now I've shown you 2 different ways that you can edit the queries as part of InfluxDB2. One is I can use the query builder. And then second, I can use this script editor, which allows me to see what the query builder actually built, and then define and enrich the dashboards that I have out there. See, I have that same error below, which I can go ahead and fix later. But the point is, I can either use the straightforward query builder, or I can use the script editor to sort of build up these style of dashboards. And it's super useful to be able to switch between them, particularly if you haven't invested in learning the Flux query language, which is relatively new. You can go through the point and click experience. It takes you a certain amount of the way. And then if you want to do more powerful things, you can click the script editor button and see what that query builder has built for you. Also, I tend to use this pretty regularly in terms of just building sort of the front matter, the from, the range, the basic filtering. And then I start to do more advanced functions and using the wide variety of functions that are available in the query language itself. And from here, you can do things like just inject the various functions that you want to have working, and then fill in the values, which again cuts down on typing. So with that, I've got a sort of an enriched and more sophisticated dashboard for NVIDIA. I've got my basic CPU temperature monitoring, and I'm able to sort of add those queries and make adjustments to them. So then next up was I wanted to be notified when the temperature exceeded a certain level. So we can go ahead into the alert section and create what's called a check. And the idea behind the check is you want to check to see what's happening. You want an analysis of the data that you're landing to figure out what's happening. So if I click on threshold check, I can come in here and say, well, let's first, I cared a lot about the temperature of the CPU. And again, I'm going to look at the various sensors, and I'm going to do that same sort of selection that we just had. I'm going to select the input for all of the cores that are out there. And once I have that, I can run that same chart. It says I have to select a field. Okay, so I selected that. Now I have to define some thresholds. So in order to do that, I can use these threshold markers and place those on the screen by going into threshold. And so like a critical level, for example, let's say if it's anything over 65 degrees C, I want to know about that. And at warning, maybe it's 50. Right. So right immediately, I should be able to get a check warning. So now that I've set that thresholding up, it's just going to say, hey, this check is at whatever level. You can modify the message template here in more detail. It's going to run every minute. Maybe I don't want to be notified that frequently. Maybe I want to do it every 5 minutes or maybe every 10 minutes because this might get a little bit noisy, but the check will actually run on that level of frequency. Now, I haven't set up the sending me the notification or to a specific endpoint. We'll come back and do that in a minute. But the idea is this check will run and evaluate the CPU temperature and then store the results of that check. It doesn't mean that you have to be notified every time the check is run or on the evaluation of the results. There's actually a way to separate those two things to prevent things like event storms and alert storms. So at least I have the check set up. Oh, I didn't give it a name, so let's do that. This is a CPU temp check. And obviously I could go through the same process for checking the GPU. So we're going to stop the demo there and let's go back to the slides. And so what I just showed you is obviously I was exploring the 2.0 open source version. I got that basic system, Linux system template, which is great. I had monitoring done in just a couple of minutes. I extended the Telegraph configuration. I downloaded the config. I added the temp input and NVIDIA input plugins to get that CPU and temperature monitoring for both the CPU and the GPU. I set up a basic check to make sure that the machine isn't overheating and evaluating that. And yeah, the next step was to basically turn that into systemd services. So every time we reboot, we're not restarting those things from the command line. So super cool, super easy. Setting up the systemd instructions are in the docs. It's very straightforward. And that was it. So I was pretty happy to get that going, except then what happened? So every now and again, I'd get a CPU check, evaluate, and say, yeah, you've exceeded that. But the machine wasn't really being used that heavily, and I wondered why. And so I kind of dug into this. My son went out to walk the dog, and he was gone for a while. So I sat down and I said, well, what's in his search history? What is he actually doing on this machine now that we built it? And there were a lot of searches for wine. And I was like, wait, you're a miner. Like, why are you searching for wine? Well, it turns out that what he was looking for, and he was stumbling across from a bunch of his gamer friends, is he was looking for this emulation software. So if you're not familiar with Linux and Wine, it exists to help provide a compatibility layer for you to run Windows-based games on a Linux box. And obviously, since we'd set the whole thing up for Linux, he was then now trying to figure out how to run his favorite Windows-based games. Well, it turns out that if you go and do just the most rudimentary search, you can find out that Windows is the most popular gaming platform by a wide margin. 95% of users out there are using Windows. And of course, what this means is it's a dad fail. So I did not, while my intentions were good in setting up a nice rig for gaming and some educational experience, he was not going to be able to utilize this for gaming, which was sad. And so then what happened? We had this all set up. He was, playing with different things and sort of learning about Linux, which is great, but not able to game on the machine. And then, of course, we entered the global pandemic. And so now we were spending a lot of time at home. And I figured, all right, so what do we need to do now? So I needed to get a copy of Windows 10, which I did. Again, back to YouTube to figure out how to do a dual boot and how to set that up on the drive and make the option so that we could switch between. We didn't really want to lose the Linux support. I'm running and off of the Linux boot mechanics on this machine today. I'm in my son's room. I'm using his headset. But the experience of installing Windows 10 was just as glitchy / challenging in that we had to go back through the ISO editor creation process, but Windows has its own little unique nuances. Then back to YouTube to figure out how to configure to boot from the USB stick again, because I forgot, doing it one time wasn't really sticking around in my memory, but we got all that going. And so then I said, well, wait a minute, if I'm going to have a dual boot machine, I know I could set up the Telegraph agents to be either System D or Windows System Services, so that regardless of which one he boots into, I will be able to get system stats. But now I can't have InfluxDB open source running. I mean, I could, but then I'd be switching back and forth between them. And so why don't I take advantage of Influx Cloud? And so I went into the sign up. I signed up for a free account. I installed Telegraph for Windows on the Windows partition that we had created. And then I found out that in the same way that we had the Linux system template, we had the Windows system template out there. And remember, when I installed that temperature plugin for Telegraph, it supported both Linux and Windows, which in this case now turns out to be super handy because I'm going to need that same plugin on the Windows side. And it turns out that NVIDIA SMI driver or SMI utility has a Linux and a Windows version, so I can tap into that as well. So virtually the same configuration setup with just some changes to the paths of where to find those underlying utilities to gather those stats. And so let's go back out now and take a look at how I've set this up in cloud. I've logged in here into my cloud account. Maybe. There we go. And I've got the Linux dashboard. I've gone through that same process of installing the template. And if I open the Windows system template and I look over the past couple of days, obviously I hijacked this machine off of Windows where he was happily using it and put it back onto Linux so I could run through the entire demo. But you can see, again, system uptime, queue processor length, network, swap, all the basics, and then just adding those additional CPU and temperature and NVIDIA elements were added to the whole thing. So I can go back in and go through that process. But what I'd like to do now is show you after you create the check. So I've got the temperature check here. I've also created a dead man check to let me know if I'm not receiving data. You create something called a notification endpoint. So if I want those checks to actually be sent to me in real time, I can create one. And so we use Slack. And so if you create a notification endpoint, the default option in the free tier happens to be Slack. There are a number of different endpoints that you can configure, but this one is available to free tier users. And all you do is give it a name, and then you give it the webhook where we can call into. And so if you work with your Slack administrator or you are a Slack administrator, you can get that set up as an integration and get a unique URL to paste in there. So I have it set up to alert me. And then you go in, and the last step is notification rules. So you define a rule, in this case, a warning. So I named it warning. Every 45 minutes it runs, and it looks for the warning status. And then it just sends me a message. It just says, hey, this notification rule is triggered by the check name, which is the temperature check. And then it gives me the message that's thrown from the check itself. And so I got that all set up, and it was great. A couple of things to note. In cloud, if I go to look at the telegraph configuration, little reload there. You can see I've got my Linux system monitoring and my Windows system monitoring here. And you can see that if I scroll down, I've got the NVIDIA SMI input in here. You'll also notice that I've set the URL, the organization, and the organization name, and I switched buckets when I moved to cloud. Instead of Telegraph, I called it default. But you may be wondering, like, how did you get that configuration in there? Oh, wait a minute, there's now a Save Changes button. And in the cloud environment today, we're actually allowing you to edit the Telegraph configuration inline. So you don't have to download it and then re-import as another template material or resource. You can just edit it straight away. And so if I wanted to, again, change things like the frequency of data collection, which again, in this case is now 30 seconds. If I wanted to change it down to 60 seconds, I could go ahead and do that. And there's some nice editing magic that, right? So that the quote now is being paired up with the other quote, and making sure that I get this all set up correctly. So you can save those changes, and then I can just restart the Telegraph agent. It'll re-pull that configuration rather than all the manipulation of downloading and back and forth, which is really cool. Okay, so that's all set up. Windows is there. I was getting the alerts. And obviously we didn't overheat the CPU, which was great. And now I was looking at the GPU side, right? So I got that template, Windows system template up and running. Same kind of experience. I extended the Telegraph configuration again, putting the NVIDIA piece in. There was one other step to do the CPU temperature monitoring. And then I defined my Slack endpoint and my notification rules. And occasionally I'd be sitting in my office during the day and I would receive a GPU temperature alert, which I thought was weird because my son was in online school. And so I ignored it. Caitlin and I were probably doing another talk or something, webcast, and I was getting these alerts and I was like, well, this is weird. Like, I wonder why this is going off. And so what I found out was the GPU temperature started going up because my son was gaming in the middle of class. And so I was getting these alerts while he was supposed to be paying attention to the teacher instead. And so welcome to parenting in 2020 and extending now into 2021. But the nice part was I had that alert. I could get up from my office, come in and check on him, figure out what he was doing. He got busted, and we got him back focusing on school. So let's see. In the final attempt here, final attempt here is what else happened. If I'm version 1 and my son is version 2, then my father is the version OG, and this is the kind of system that he worked on. And of course, during the pandemic, and we're looking for some more projects to do, my father decided to give my son a gift, a Raspberry Pi for Christmas. And of course, what that means is it's more work for version 1, which is me. And so then what did I need to do? Turns out that I got that gift. It's the gift that keeps on giving. Great environment to learn programming languages like Scratch. It's got the open pin board on the back. And if you haven't seen a Raspberry Pi 400, right, it's essentially everything packaged into an individual keyboard. It has Wi-Fi. Yeah, great. And one of the big differences for me, to be honest, was that it comes with a tool called the Raspberry Pi Imager, which allows you to create those ISO images for getting different operating systems onto the box. Way easier than anything that I had. I didn't even need to go to YouTube for this one. Just the imager is there. You can choose the operating system and burn it onto an SD card and just boot the machine directly from there, which is great. Now the Pi 400 and the Pi 4 series is actually an ARM V8 chip. And so we actually just introduced InfluxDB open source 2.0 on the ARM chip for 64-bit, which is ARM v8 and above. And so I re-imaged the Pi from the default Raspbian operating system, which was 32-bit, which is what it shipped with. And I upgraded it to use the latest Ubuntu Groovy Gorilla version, which supports the 64-bit ARM chip, which is great. Super easy to do. And then again, I went back to cloud and said, well, I can probably figure out how to scrape the data off the Raspberry Pi. Just get the Telegraph agent collector downloaded and put it on the machine. And it turns out that one of our community members, Ivan, over in the Czech Republic, had actually already built a Pi template. So I picked it up and deployed it. And so let's take a look at that. So let's go back to my my cloud account, and we'll go to the community templates, and we will go into Raspberry Pi again, alphabetically listed. We'll grab this URL. And we'll pop it into the template. You can see I've done this a couple of times. And one of the things on the templates, by the way, that you can check out is there's always these README instructions. And this tells you if there's other things that you'll need to set up. So in the case of the Raspberry Pi, there's a bunch of options here. So if you're using the default Raspberry Pi OS to pick up the temperature command, that utility is located in one directory, whereas if you're using Ubuntu, it's located in a separate directory. And so you can see all that sort of outlined here. It also tells you about the URLs and the organization setup you have, as well as the token setup that you need to go through. So we'll go ahead and install that template. And there it is. And we can go back to look at the Telegraph config. And here it is. And we will look at this one. So this is the one that I've already edited, where I've included the default URL, my organization, the bucket name is provided by default. And you can see down here that it's got the temperature input. And a lot of these look like the general Linux system monitoring template elements that we had previously. In this case, I'm using the exec plugin call out to that vcgen command to grab the GPU temperatures. And so I can go to the dashboard that was loaded, and I can click that. And in theory, we should see all of the values that are here for the Raspberry Pi. So Raspberry Pi bucket, that Raspberry Pi host within the past hour. And actually I can roll this back a little bit and we can get a little bit longer view of things. So that's been running now since Christmas, and I've gotten the monitoring stats. And it's nice. I've got this CPU and GPU temperatures sort of side by side to make sure we see what's going on there, and I can wire that into my alerts. So there's a few more things I'd like to be able to do with this, and we'll talk about that next. So again, like installing that template, super easy. I didn't have to really do much other than configure where it was going to scrape that GPU temperature, which is very similar to the way that we adjusted that for the NVIDIA template. And obviously, I went through those instructions in the README, but basically got it set up. I can go through that similar alerts and notifications setup to add a check specifically for the Raspberry Pi. But if I take a step back and think about it, I think the things I want to do next with this are, number one, since the template actually comes and loads the data in a separate bucket within InfluxDB, but the stats for Linux and the Raspberry Pi are very, very similar, if not identical in terms of the measurement names that they use. And so I can save on a bucket. You're limited to 2 buckets within the free tier of InfluxDB Cloud. And so I could probably then just merge the Raspberry Pi data in with the Linux data. Again, I'm only monitoring, a few machines at once. And so, yeah, saving on bucket would be great. Then that also simplifies my alerts check. The alerts check can just look in that single location and let me know which host it is that my son may be sitting on, whether he's now playing with the Raspberry Pi or whether he's sitting on the Windows rig. And then the other thing I could do is I could look to the NVIDIA data for the GPU and the Raspberry Pi GPU data. While they have the same measurement name, they're they have the same, they could be flowing into the same bucket and they have the same field structure. It's called temperature underscore GPU. They're actually in different measurements. The NVIDIA SMI data resides in one place and the Raspberry Pi data resides in a different location. And so one of the things that you could do is you could set up a task that actually takes the data from each of those locations and merges it together and then run the check off of that. And then again, trying to consolidate the number of moving parts here. And so this is a super common thing that will happen in the real world, right? Which is not just this scenario where, Tim is doing this at home to try to be a better parent and checking on these things, but like there's frequently data that you receive from multiple sources that you would like to land in a single location to just, again, simplify all the moving parts. I don't want to have to create a check for every individual type of thing. I can actually coalesce those things together. And then obviously modify the alert check to read off of that downsampled data. If I'm receiving this information, once every 30 to 60 seconds, maybe I want to look over a longer time horizon. I don't need to be checking on my son every minute. He's growing up. He's mostly responsible, except for occasionally trying to game during school. And so, if it checks every 15, if I'm notified every 15 minutes, or I extend the mean of the temperature over a longer period of time, or look for a max within, those time periods instead of trying to average things out, that may be giving me better signal. So again, within the platform, you have the ability to go through and set up a task, right? Where let's say what I really want is I want to get this GPU temperature data, but I also want to get the, let's see if we start off with that. And I go into the script editor. I could then say, this data is, this is the NVIDIA data, and I can set that up. And then I could come back and do a very similar kind of query, right? Where I say, make sure I spell it right. And I could say, oops. And I'm going to get that from Raspberry Pi bucket. And I'm looking for that piece. And I'm looking for temp. And I could run that. And oops, let's see. Oh, because I've have two different data sets running in there. I need to do a union. So I want to join those two things together. Let's union both of those. So I'm going to union NVIDIA. And the Raspberry Pi results. And let's see if we can get that. I'm going to change the raw data view so I can see what it outputs. Okay, looks like I have a little more work to do there to shape these two things together. So anyway, the basic idea though is to build up one data set from one bucket, build up the second data set from the second data bucket, union them, and then output them to a common location that you can run your check off of. All right, maybe I just don't need the quotes. Well, let's try that real quick. All right, well, this has to have a unique name. Try that. There we go. All right. I should have followed the instructions. So now you can see that I've got the different data elements in here from the NVIDIA side and from the Raspberry Pi side. And what I can do now is go through additional data shaping mechanisms, like rename the measurement. So there's a function called map, and I can use the map element to add or update to a common measurement between the two, and then use the to function to write it to a subsequent bucket. And once I have that all done, I can save it as a task where it runs and tell it where to put the output data, etc. And so now I've consolidated all that effort. All right, so that is it. We are on to Q&A, Caitlin, with a few minutes left. Let's stop the share. We can pop the chat open and see what we've got.
Awesome. So I actually got a question before even you started over email. So I use InfluxDB locally, Telegraph, and Grafana. I would like to add alerts using Slack. The webinar proposing InfluxDB, Telegraph, and Slack. Can I make the same connection to Slack with a local InfluxDB instance, or do I have to migrate my database to the cloud?
Nope. You should be able to take advantage of the Slack setup, but you have to have a Slack account. Actually, one of the things we can do is let's look at the documentation, which is super helpful. So let me share that. Lost the Zoom window. There we go. So if we go into the docs, you'll notice that in the documentation, there's two separate links. There's docs specific to cloud and docs specific to open source. We actually update the cloud environment 25 to 30 times a week, whether it's small defect fixes or feature advancements. And obviously the open source edition is going to be specific drops that happen over time. And so we've separated those two doc sets to be unique based on what's available in each of those instances. So if you look at in the version 2 docs, if you look under.
Tim, are you, did
sorry.
You want us to see your screen?
Yeah, sorry about that. It helps if I click that button. So first there's the separation of the two. So you've got cloud docs and 2.0 docs. And if I click in there, you'll see under process data, there's how to get started with tasks, which I was showing at the end. And then under monitoring and alerting, it talks more about checks, notifications, rules. And there's even some examples of how to set up using third-party mail services. So if you wanted to send an email rather than being alerted through Slack, let's say you're not a Slack user, you can create a custom task that will allow you to send to any of these mail service providers, Mailgun, Mailjet, Amazon Simple Mail Service, or SendGrid. And it just walks through exactly what you need to do in terms of creating that custom task and how to manage it. Within Flux, there are also a ton of different alert endpoints that you can set up, again, in a similar fashion to this. So if you look under the Flux standard library, you'll see things like PagerDuty, which is available in the paid tier, but you can do it through open source as well. There's also contributed ones. So if you use Discord, obviously my son is using that as well. There's OpsGenie, there's Sensu, there's Telegram, there's Microsoft Teams, and they all can be used in a similar fashion. Create a custom task to send your notifications wherever you want. So hopefully that helps.
Awesome. And someone pointed out, so they're using Grafana to visualize what Telegraph has collected into InfluxDB.
Yep.
And he noted that your data viewer looks a little bit different. What are you using to explore your data?
Well, I was using the native UI that comes with InfluxDB. So if you're not aware, that was a big addition that was added both to the cloud environment and to the native open source. Not a separate process, not a separate thing. And again, that whole notion of templates, where the template can include everything from variable definitions to labels to the buckets to the dashboards, can all be packaged up into a single unit. And if you want to do things like source code control or sort of a GitOps style workflow, there's a webinar by one of my colleagues, Russ Savage, that really walks you through how to do that. And what we found was it was difficult to try to package all those things together if you're using Grafana as a visualization engine, which again, Grafana is a great partner of ours. Many people use it, particularly in environments where they have multiple data sources that they want to manage and interoperate with. But for us, we wanted a unique experience that you could leverage and take advantage of all the things in the platform ecosystem, all in sort of one sort of package. And so that's what we've offered. Where we're going next in terms of the user interface is we're actually, the dashboarding experience is sort of one destination, but it's not the only one. What we're talking with customers about and community users now about is how we enable sharing and collaboration. And so there's some YouTube videos out there, a concept that we're piloting with a few folks called notebooks. If you're familiar with Jupyter notebooks or that sort of style, we were a little bit inspired by that. But the idea is, how do we help drive sharing and collaboration where you can invite someone to see how did you construct that particular dashboard, or how did you construct that task, break it up into a series of steps, and provide you with a unique experience for how to assemble those kinds of things. So hopefully that helps lays it out. By the way, Grafana is totally still supported as part of InfluxDB 2.0. So, and if you look again in the documentation, there's a section called Tools and Integrations, and you'll see in here about using Grafana. You can click on that, and it gives you all of the setup instructions for how to do that. If you're coming from the 1.x world and you've been heavily using InfluxDB and you're looking at this saying, Tim, what the heck was that language you typed all those commands in? That's Flux. That's the new query language. It's the core part of the extensions and improvements that we made to 2.0. And what we're trying to do is provide you with more access to the data using a scripted style language instead of the SQL syntax that we used to use for InfluxQL. But InfluxQL is supported in compatibility mode, meaning if you were using Grafana and you have a whole ton of dashboards that you were already using, you can configure Grafana to use InfluxQL. What you'll need to do, though, is make sure that you're using the command line utilities to set up the authentication mechanisms. And so I encourage you to look through, reading through the compatibility docs of how we've maintained compatibility between versions. And the one specific tool that you'll really want to dig into is this InfluxDB v1, which allows you to create the v1 style authentication, which is username and password driven, not token. And you'll want to create mappings between the bucket, which is a new concept in 2.0, which combines the notion of database and retention policy into one. And so there's a way for you to map your existing database and retention policies into those buckets to allow the whole thing to hang together. So definitely check out all of that, including the upgrade process. So if you're an open source user and you go through that upgrade process, there is automated steps which will take your existing users and port them over. It will create those database and retention policy mappings for you automatically. And your Grafana instances should just continue to run in open source. We're working on some tooling to allow people to move from open source to cloud, effectively extract that same information and inject it into a cloud account, and look for that coming up by the end of Q1.
Awesome. Will this also work on Raspberry Pi 3B?
It will, but you're going to run the Telegraph agent, which is the ARM HF version, which is for ARM version 7. So just look out for that. There is no 32-bit version of InfluxDB open source. So because of that, definitely sign up for a free cloud account and start there.
Perfect. Does the Linux InfluxDB template work for all Linux versions?
It should.
Okay.
It should. My suggestion is try it out. What you'll see is if there's a problem, for example, I'm going to go here. And by the way, if you didn't notice, my son named the machine Destroyer because, yeah. Anyway, that's what you do.
Kid.
Kids these days. So when you start up the Telegraph agent, it will give you error messages after it loads up the inputs. If it attempts to execute any of those and it can't find, like, for example, if I had the NVIDIA SMI utility in the wrong place, which I did, it gives you an error message after it runs through the configuration and attempts to contact the plugin the first time. And so the answer is yes, it'll tell you. And then what you would do is, if you're using the cloud, you can comment out the plugins that it's complaining about, and then try again. That's the way to go. If you're using the open source, download the config, just comment them out locally, and then point the Telegraph agent at that config and restart it until you resolve those issues.
Cool. All right, we still have a bunch of questions here. So this is continuous gaming data. Sometimes time series data also appears to be momentary, meaning time series data comes in batches and turns off before coming in again. How does InfluxDB manage such discontinuous or transient data?
So that's more a question of the data movement from source to target. So today, Telegraph has a lot of different plugins. There's almost 300 plugins now that exist for Telegraph that's used to move data around. But you don't have to use Telegraph itself. Obviously, the APIs are exposed. And if you looked, let me reshare that again. There is, if I can find Caitlin's face, there she is. Hi, Caitlin. If we go back into the platform and we go under the data section, you'll notice that the under sources, not only do we have the Telegraph plugins listed, but there are a set of a dozen, with 2 more coming, one for Swift and one for Flutter and Dart client libraries. So if you're operating or building applications within any of these language environments, you can grab the client library and build your own mechanism to transfer or transmit the data from source to target. Other mechanisms and integrations that exist out in the world that you might be able to leverage for this, for data movement, particularly when data may be transient in nature or batched in nature. There's something called Apache NiFi, which has connectors for InfluxDB 1 and 2, where you can feed data in and ensure that the data will get from source to target, fully open source, courtesy of the NSA, who contributed that tech, which we thank them very much for. But it's a great way if you're moving batches of data, or you have very infrequent data, to ensure that it moves from source to target. What that also may mean is that you don't have consistent internet connectivity, which is another problem. So we have a community user who has ferry boats that get too far away from the cellular connection. Telegraph will buffer up the data for some period of time, and that is configurable, but then it'll start losing data if you don't return to a connected environment. But there's lots of ways for you to move the data around in bulk. One of the things that we're doing upcoming for the cloud environment in particular is we will have a bulk data ingest mechanism that is self-service, and it'll operate off of an object storage location. So if you've purchased or if you're using your cloud account inside of AWS, then obviously you can use an S3 bucket and bring data in that way. If you've batched it up, stored it in a file, and you just want to drop that file in, we'll provide the mechanism for you to be able to do that in the future. So look for that probably in Q2.
Perfect. Tim, do you have a little bit more time? There's a couple of good questions here.
Sure.
Okay. Can I do HTTP alerts from my local instance?
Yes, you
Okay.
can. And that is covered in, if you just look at the Flux language and the standard library, you'll notice HTTP is here, and there's tons of examples for how to configure the post function. And you would use this in a task in the same way that the this send alerts email is structured, but instead of sending it an email, just use HTTP post. And so the example of how to do that is here.
And while you are sharing your screen, can you go over the Slack integration a little bit more? I'm sure it's in the docs somewhere.
Sure. So if we just look at Slack, there's really only two parts to it. So what the UI is doing for you behind the scenes is the alerts and notifications system that layers on top is actually generating for you tasks underneath. So we're using our underlying task system, but we're presenting it to you in a sort of easy to consume fashion through the user experience. So what happens for the Slack setup is when you configure a new Slack endpoint, you just put a name in there, you can give it a description, and all you need to do is add the webhook URL. What happens behind the scene is obviously I'm picking up these elements. I'm picking up the Slack endpoint, the URL, and you can specify a specific token to use with Slack, and it defaults to blank. But if you want a higher degree of security, obviously you can add that. But that's kind of it. It's pretty straightforward.
Great. How much how much resources does Telegraph take up? We run high speed execution and consume 4 terabytes of data daily. So we need something lightweight.
Yeah, Telegraph's super lightweight. I mean, I have it running on a Raspberry Pi, right? And it was collecting all those stats. So few percentage max of the CPU and network. And you can obviously configure the frequency of data collection locally as well as the flush. If you start to go out into, creating your own call outs, like the exec plugin that I showed you that calls out to the VCGen command on the Raspberry Pi to grab the CPU measurement, you can really call out to any utility. If you start going down that path, the odds that you are doing something heavier weight that may consume more resources go up. But if you stay within the plugin set that's available, generally speaking, Telegraph just runs. And we hear that from our community. It's running on millions of servers worldwide. And yeah, people have really, really good luck with it being the sort of lightest weight data movement, data collection and movement agent out there.
Awesome. Okay, one last question. I know we're completely over. I have a Raspberry Pi 4 gigabyte sitting around doing nothing. I would like to monitor some computers and Wi-Fi routers. Do you think it will be enough, do you think it'll be enough to test with the free cloud edition?
Yeah, should be. I would say the biggest thing when you look at the with cloud, right? So you got kind of two options, right? You could flash your Raspberry Pi 4 to the Ubuntu 64-bit edition, and then download obviously the ARM package for Influx open source, and then you just use that as a collection device, or you can sign up for the cloud account. And the main thing to be aware of, right, is there are obviously limits. And so, when you're using cloud in the free tier, there are, let's say, where is it? It's in here, limits. Key concepts. There are limits to all the things that you can do with the cloud, right? So, here it is. It's under account management. So you'll see things like data usage. So from a pricing plan perspective, within the free tier, you can feed in 5 megabytes every 5 minutes, and you can query 300 megabytes every 5 minutes, and you get up to 30 days free, maximum of 10,000 cardinality. And then there's limits on the number of resources that you can create. So 5 dashboards, 5 tasks, 2 buckets, 2 checks, and 2 rule notifications. And obviously the idea here is trying to give you some surface area for free. And then if you need more, obviously you can purchase that. But that's why I was saying, if I've got a bucket for the general Telegraph things, and then I have a separate bucket for Raspberry Pi, maybe that doesn't make a lot of sense. I can combine those into the same bucket, plenty of measurements, and leverage them together. So all that's possible here. But it's just going to depend on the volume that you write. So if you reduce the data frequency in through your Telegraph agent to something underneath that threshold for all the devices that you plan to match, then it should be good to go.
Awesome. Thank you so much, Tim. I know we've gone completely over. Thank you, everyone, for joining today's virtual time series meetup. If you have any questions for us, please feel free to email us or post in the community Slack. We're always there to help. And if you have any projects that you're using InfluxDB at home and you'd like to present at one of these, please feel free to email me. We're always looking for speakers. Once again, the session has been recorded and will be made available on YouTube later today. Thank you so much.